Good morning to all. Today I will deliver lecture on gear and gear trends, one of the chapter from KTOM. Outline of today's lecture: gear trends. In that, first definition, then types of gear train, speed ratio, turn value, and tabular method for finding speeds of elements of epicyclic gear train. Gear train. So in the figure, a series of gears is shown. So this one is the driver, this one is the idle gear, and this one is the driven gear. So any combination consisting of two or more gears used to transmit power from one shaft to another is known as gear train, or a system to generate power and speed. So sometimes two or more gears are made to mesh with each other to transmit power from one shaft to another. Such a combination is called as gear train or train of the two-three wheel. The nature of gear train depends upon the velocity ratio required and relative position of axis of shaft. A gear train may be consist of pure gear, bevel gear, or spiral gear. Now let us study types of gear train. So there are four different types of gear train. First one simple gear train, second one compound gear train, third one is reverted gear train, and fourth one is epicyclic gear train. So first simple gear train. In this type of gear train, there is only one gear on each shaft. So for example, gear 1 is mounted on shaft 1, gear number 2 is mounted on shaft 2, gear number 3 is mounted on shaft 3, and gear number 4 is mounted on shaft 4. Here only one gear on each shaft, therefore it is known as a simple gear train. So with respect to this gear train, speed ratio is defined as speed ratio of speed of driver to the speed of the driven, and this speed ratio is nothing but ratio of number of teeth on the driven to the number of teeth on the driver. So with respect to this simple gear train, a train value which is a reciprocal of the speed ratio, which can be defined or which can be write as ratio of speed of driven to the speed of the driver, and is equal to the number of ratio of number of teeth on the driver to the driven. Then second type of gear train, that is compound gear train. When in a series of gears, when there is more than one gear on one or two particular shafts are mounted, then such gear train is called as a compound gear train. Here at the input there is driver, again gear number 2 and 3 is mounted on shaft B, gear number 4 and 5 is mounted on shaft C, and gear 6 is mounted on shaft D. With respect to this, the speed ratio, that is N1 upon N6, is equal to T2 into T4 into T6 divided by T1 into T3 into T5. So here the speed ratio is dependent on the number of gears, number of idle gears, or number of the gears which are placed between the driver and the driven. Then third type, that is reverted gear train. In this type of gear train, we can observe that the input and output gears are coaxial. So direction of these gears is same. So distance between centers of the shafts of gears 1 and 2 as well as gear number 3 and 4 is same, then such type of gear train is used. In this case, speed ratio is equal to N1 upon N4, that is N1 is speed of driver and N4 is speed of the driven. Here note that gear number 2 and 3 are mounted on same shaft. So therefore it is also called as a reverted compound gear train. So similar to the compound gear train, we can write the train value for the same N4 upon N1 is equal to T1 into T3 divided by T2 into T4. Then last type of gear train, that is epicyclic gear train. In this gear we can see gear B is in mesh with gear C and there is one arm which is having two center, one is O1 and O2. Gear B is free to rotate about O2, gear C is free to rotate about O1 and in between that arm is there. In this gear train, at least one of the axis of the shaft move relative to the fixed one. So such type of epicyclic motion occurs in epicyclic gear train. Therefore, such a gear train is called as epicyclic gear train. Now, usually for simple compound and reverted gear train, we have seen that the velocity ratio with respect to the input and output gear can easily find out just by visualizing those gear trains. But in case of epicyclic gear train, by providing the conditions to the particular element, it is difficult to find out the velocity ratio just by observing the combination of the gears. So therefore, there is one method which is called as a tabular method to find out velocity ratio of epicyclic gear train. Here again the epicyclic gear train, a simple combination is shown: gear A, gear B, arm C. This is called as epicyclic gear train. Now in this method there are 4 steps. With respect to first step, we need to fix this arm. Arm is fixed and gear A rotates through plus 1 revolution, that is 1 revolution in anti-clockwise direction. So therefore revolution of arm will be 0. When arm is fixed, gear A is rotated through plus 1 revolution. Then we need to find out revolution of the gear B when A is rotating with plus 1 revolution in anti-clockwise direction. So B is in mesh with A, so therefore we can write train value as NB upon NA is equal to TA upon TB. So what is value of NA? So that is NA is equal to 1, so therefore NB is equal to TA upon TB. So TA upon TB, this is the train value, and we have included minus sign because when A is going to rotate in anti-clockwise direction, that we have considered positive. B will rotate in clockwise direction, that we need to consider as a negative. So second step, again arm is fixed, gear A rotates through plus X revolution. So again 0 plus X, just we need to multiply first row by plus X, and again we are going to get the minus X TA upon TB, that is revolution of the B. Then again to count revolution of arms, we need to add plus Y revolution to all the elements, that is plus Y plus Y plus Y. Therefore, and step number 4, we are going to get the total motion, addition of this 0 and Y, that is to Y, again addition of this X and Y, X plus Y, addition of this term and this term, Y minus X TA upon TB. So by knowing 2 conditions among these 3 elements, suppose we know rotation of the arm and rotation of the A, then we can find out the speed of B. Or if arm is known, speed of arm is known, speed of B is known, then we can find out the speed of A. Now let us take one example. In an epicyclic gear train, as shown in the figure, the number of teeth of wheels A, B and C are 48, 28 and 50 respectively. If the arm rotates at 400 rpm clockwise, find speed of wheel C when A is fixed and B speed of wheel A when C is fixed. So with respect to this example, now we need to formulate the table of motion, serial number, conditions of the motion, arm A, B and C. Now for this combination, arm is fixed, gear A rotates through +1 revolution, therefore arm is equal, revolution of arm is 0. A, it is going to rotate in anti-clockwise direction, +1. Again we got the train value as a TA upon TB. This is for B. We have inserted minus sign as it is going to rotate in clockwise direction. Again with respect to this C, as C is in mesh with B, we got the train value as TA upon TC. Again not necessary to put the sign as it is going to rotate in the anti-clockwise direction. Now second column, again we are going to multiply by plus X to all first row, add Y revolution to all total motion. We are going to get this last column as a total motion. Now find the speed of wheel C and conditions they have given. Y is equal to minus 400. That means 400 rpm clockwise we have given minus sign, and A is fixed. That condition they have given, therefore X plus Y is equal to 0. So we got the value of X is equal to this 400. Now speed of C is equal to total motion of C. Total motion of C is equal to Y plus X TA upon TC. So therefore this NC is equal to Y plus, we are going to put the value of X and Y. We are getting value NC is equal to 16 rpm clockwise. Similarly, we can find out the value of speed of wheel A when C is fixed. Again we are going to get the two condition, Y is equal to minus 400 and Y plus X TA upon TC is equal to 0 as C is fixed. From this we can get the value of X and Y, and finally we can find out the speed of gear A, which we got 16.67 revolution in anti-clockwise direction. Thank you.